So my name is Nick Larsen. I have been a software developer since I was 11. I've been at Stack Overflow now for about 5.5 years, and I'm here to talk about WebAssembly. The first thing is, what is WebAssembly? I don't know if too many of you know, but I'm going to give you a little bit of history on JavaScript in general to kind of explain what the goals of WebAssembly are. Basically, about 10 or 12 years ago, things were kind of cool. You know, we had some single-page apps coming online that were like Google Maps and Gmail, and things were kind of looking up and everything was cool. We were getting regular new JavaScript APIs, things kept moving along. But anytime we tried to do anything really interesting, like, I don't know, play a 3D video game in a web browser or create like Photoshop in a web browser, we ran into like a perf wall real fast. So if you fast forward then to about 2008, Google releases Chrome. Now, Chrome was like a revolution for web development for at least two reasons. One was that within a couple of months of its initial release, it was fully HTML, CSS, and JavaScript compliant, which means as long as you followed the spec, it ran in that browser just fine, and that wasn't true of any other browser. The second reason was that in their new JavaScript engine, they introduced a Jit Compiler. What a Jit Compiler does is take portions of your JavaScript code and compiles it down to machine code and lets it run directly on the metal instead of being interpreted by an interpreter. This was like a huge performance win across the board, and immediately the browser performance wars were on. So if you fast forward again to 2012, in 2012 you have three main vendors now. You have IE, which is still kind of hanging on because they had such a huge market share to begin with. And then you had Chrome, which is creeping up, and you had Firefox, which was staying in the mix even through these. All three of these different projects were moving in different directions, but they were all making huge strides in performance. IE was focused almost entirely on hardware acceleration. This was very interesting if you wanted to do something like, I don't know, put 1,000 fish in a fishbowl on a website, because that's what all of their demos were about. And then there was Google. Google was focused more on real applications, and the real applications were all single-page applications. You know, they had all of like Google Docs coming out and things like that. And what they focused on was writing a compiler that didn't compile your code one time, it would compile your code multiple times. And each time it would get better because it recorded statistics from the previous time that it ran, and then use those statistics to build a better model for how to compile it. This was, again, huge performance wins, especially for single-page applications, which is what they were focused on. Then there was Mozilla. Mozilla was focused on a lot of different areas. They were mostly research projects. One in particular was this idea of capsules, or what's called a module. Now, a module is like you take a very small subset of what your application is and you package it up into this thing, and you set it aside and we can optimize the crap out of that. And so they came out with a bunch of different kinds of modules, but one in particular was called asm.js. I hope you've heard of that if you're here. If you haven't, what asm.js is basically a very small subset of JavaScript that you write that looks a lot like C code. The only thing it allows you to do is bit manipulations on a byte array. For the most part. You can do like multiplications and stuff like that, but if you wanted to do anything interesting, write to the console, do any kind of debugging or anything like that, it was pretty much out the window. And the trick to this is it allowed these components to be compiled as if they were statically typed instead of dynamically typed. In a dynamically typed language, every time you call a property, every time you call for an object, you have to check the type of that object. That incurs an overhead, and let's say that you have a property, and then you call a property of that property, and then you call a property of that property. You incur this overhead repeatedly every time you call an additional property. In statically typed language, you know what the type is, so you don't have to go look it up, and all of that trouble is removed. So this is what they were focusing on with asm.js. Now, basically, if you forward to about 2014, they decided they were like, hey, this thing is actually kind of cool. We've done some really interesting stuff. They made 3D games in a web browser. They did Doom. They did some really interesting stuff like that. And so they decided, let's go ahead and make this a specification. Up until that point, it was only run by Mozilla. And then they wanted input from all of the major browser vendors, so they created WebAssembly. Now, WebAssembly also has one extra benefit, and it's still a benefit of asm.js, but it was sort of one of the things that was kind of not really thought about at the time, but I think is actually going to turn out to be a killer feature, which is that you are compiling a statically typed language to JavaScript and getting the full advantage of a statically typed language. Now this isn't limited just to C, which is what they did for their example. You can do this with any language. And all the languages can be compiled to JavaScript. Now we've been compiling to JavaScript for a while with like TypeScript, and if you go all the way back to 2007, I think we had like Google Web Toolkit was compiling Java to JavaScript, and there's just tons and tons of these today. So the advantage now is that whatever your main language is that you're super happy writing in, what if you could just write that and it just ran on the web, right? This is what we're looking at in the future, and I'm talking about the next 3 to 5 years, not like 10 years from now. This is coming down the pipe. Now WebAssembly is not exactly mature, so if you try to look for a specification online, you're going to be kind of stopped cold. You have to follow it regularly, and I'm actually going to show you that the example that I built for this stopped working in Firefox about 2 days ago. So with that, I guess let's take a look at the demo that I built. All right, so for this demo, I decided to make something that would be extraordinarily slow. So I did a really bad implementation of a Gaussian blur. Basically what this is it takes one pixel and then it grabs all the pixels around it, and it takes a little bit of each of their color components, averages them together to blur it just a little bit. This actually has a lot of interesting uses. Like for instance, you can see the edges here. It should remove those edges pretty effectively. So if all we do is copy the original image, obviously it doesn't take very long at all. If we use asm.js to do this instead, and right now I'm in Chrome. That's another thing I should mention, that WebAssembly isn't exactly one of those things that you can just pull out your normal Chrome and use it, or your normal Firefox and use it. You actually have to go, for Chrome, you have to grab Chrome Canary, which is a totally different browser, and then you still, even after you do that, have to go to, oh wait, is this Firefox? Yeah, here we go, Chrome Canary. Even when you're in here, you still have to go to Chrome. This is so much easier when you can use both hands. Just go to Chrome Flags, and then search for WebAssembly, which I'm not in Chrome Canary. What the crap? I have no idea what I'm in anymore. Click on down here. No, this is it. There it is, WebAssembly. And you have to actually enable it still. In the settings, restart Chrome. Same thing's true of Firefox. Instead, you go to About Config. Same idea, search for WebAssembly and enable it, restart your browser. Once you've done this, you can then hop in here and start playing around with it. So the only thing I want to point out about this demo is this code is all available. You can go to my GitHub. It's GitHub/Nick Larsen. You can play around with this if you want to. I want to show you that it's not exactly going to do what you think it's going to do. Even though it's built for performance, it's not quite there. This is a very, very early implementation. So this asm.js stuff has actually been around for a while. And when you run it, see it takes about 2.2 seconds. I made a little hand-coded version of this, and if we have time, I'll show you. Runs just a little bit faster, but the real reason I did it is because it's more human readable. When you use the normal tool chain for this, it actually generates this crazy code that is not human readable at all. And then the last one is WebAssembly. Now this is the one that's going to surprise you. Oh, not available. Why? Because it broke. But if we go to Chrome, and we try it out in Chrome, we will see that it'll work in here. It's just going to take forever. It's a very early implementation. This is one of the cases where Firefox actually beats Chrome on a regular basis. And that's pretty much it. I'm here to answer all your questions. If I took too long, then I'll be around. You can ask me later, or if you have anything right now.
Can you show us the ASM code here?
Yeah, absolutely. So ASM code comes in two different flavors. One is just byte code. You can't really read it. And then, how do I do this here? All right, so if we go to Gaussian blur. And this is what it actually ends up looking like for asm.js. This is using a compiler called Inscripton. And what it does is it takes a C code, compiles it using LLVM, and then turns that into JavaScript as asm.js. And then what you do is there's another tool called Binarian, which will take this code and compile it to WebAssembly. So like I said, it's a tool chain, but eventually we hope to get to the point where you write it in like C# and it compiles straight to WebAssembly. It's like I said, it's not super readable. And then there's another way, but I'm sure this is not going to work. Oh wait, hold on, I pulled it up. This one. All right, so this is what the original C file looks like to do it. And then if we look at what is actually WebAssembly, it's this. It's like a derivative of closure.
Look at the outlines of that.
Oh man, that goes on for miles.
Wait, so he uses S expressions, or is that the syntax tree?
So this is what's called S format. It's not a syntax tree. This is basically like their implementation of the human readable form of this bytecode. And the idea is that when you right click and say view source, they're going to maintain that that is always possible even with WebAssembly. This is what you'll see. So knowing what language it came from, unfortunately there's not going to be any way to do that without maps, and I don't know what people are going to be willing to do with that. That's it. Any other questions? Yes?
Would you be able to send the code to everyone who hadn't looked at it?
Yeah, of course. You can just, this is all public on my GitHub. If you just go to GitHub.
He's just asking, can you go to meetup.com and put the link on?
Oh, put it on there. Yeah, sure, of course. And actually, I was going to do a whole thing about the tool chain, but I didn't have enough time as a lightning talk, so I'm just going to write a blog post about it to give you an example of how I actually went through and built all of this stuff.
Right, what's the site?
Oh, GitHub/Nick Larsen. That's a L-E-R. What? I'm not on the internet. Somebody else is going to have to go there. Sorry. Yes?
I'm vaguely familiar with ASM.js, but not really WebAssembly, but is there, due to browser sandboxing and everything like that, do you really actually have, let's say if you're running C, I would assume you still don't actually have C-level hardware control as you would, right? There's still some type of sandboxing going on, right?
Yeah, absolutely. For WebAssembly, it's compiling to just bytecode, and then whatever the browser wants to do with that bytecode, it's going to do with it. I'm sure all the vendors are going to do it in a different way because that's why they're different vendors.
But if you wanted to, say, interact with the GPU or something like that, they're still going to be involved, right?
Yes, sort of, but they're actually covering that already a little bit, especially Mozilla. Mozilla is super focused on SIMD instructions and talking directly with hardware. That's what a lot of their research projects are about right now. But as far as the ways that they've done it is they basically give you a C header file, and they're like, you can use these functions in the C header file, and then that compiles to whatever, and then they take that into their own linking.
Okay, so you're basically doing whatever specific hardware support you can't go and pull in other C header files to interact with those hardware necessarily.
No, absolutely not. Yeah. Anybody else?
Do you know how it handles memory? I guess it's still the browser, it's still garbage collected and everything, or since you're coming from an old language, do you malloc and free and?
Yeah, actually, when you use so basically the whole idea of this container thing is that you create an array of memory, just an array buffer, and you tell it the size, right? All you can do is byte manipulations. So you give it a buffer, and then you create wrappers for that buffer using typed arrays like. Let's see if I have an example right here.
It's like the window on the array, right?
Yeah, yeah, exactly. Yeah, but so what it does is there's different kinds, right? You have like a float 64 array, you have a uint 8 array, you have a uint 16 array, etc. So if you want to request a 16-bit value, you just use the specific wrapper that you want and tell it the exact byte, it'll go to it. Now they do force you to do aligned reads, so you can't read from an odd address, for instance, if you're looking at an integer, like a 4-bit integer.
So it comes in a binary, not like a JSON object or anything like that?
No, it's not a JSON object at all. So it is a binary when you're doing actual WebAssembly, but there's a fallback that uses the S, and it's just an interpreter. It uses that S code that I showed you. And that's just so that you can keep working on development while it's going through all of these early stages. Eventually they're going to get rid of that. I mean, it's like ridiculously slow, but you can run it. Yes?
You said a little bit about, you mentioned that the premium compiler, I was reading a little bit about, so if you write in C++, you can write directly to WebAssembly to be compiled directly to WebAssembly, or?
I mean, directly is one of those things where it's compiled by the LLVM compiler into whatever its representation is, which I believe is just an AST. And then it takes that and it compiles it to asm.js, and then there is a tool, all binarian is a tool that takes existing asm.js, so you can take any one of these asm.js files and compile that to the binary, the WebAssembly binary. Anybody else? All right, well, I'm going to hang out and give Ben some time here to go. If you have any questions, feel free to hit me up afterward. I'll stick around as long as you guys want to ask me questions for, or until they kick us out. And I'll learn at least a little bit.
Great. Thank you.